Hello guys, now let's look at some of the various techniques of separating the components of a mixture. Different methods of separation are used to get individual components from a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like hand picking, sieving, filtration that we use in our day-to-day life. Sometimes, special techniques have to be used for the separation of the components of a mixture. So the first one is, how can we obtain colored component, that is dye, from blue or black ink? Ink is a mixture of dye in water. Thus, we can separate the volatile component, the solvent, from its non-volatile solute by the method of evaporation. In this, what we do is, we take a beaker filled with water and keep it on a burner. On top of this beaker, we take a watchglass filled with ink. Now, in spite of directly heating the ink, we heat the water, which in turn heats the watchglass and the ink that is present in it. And due to the evaporation, we separate the solvent from its non-volatile solute. The next one is, how can we separate cream from milk? For separating cream from milk, the process of centrifugation is used. Centrifuge machine separates the cream, which is lighter than the milk, on top of the milk. After the separation, cream can be filtered using a filter paper. Some applications of centrifugation techniques are: it is used in diagnostic laboratories for blood and urine test. It is used in dairies and home to separate butter from cream. It also used in washing machines to squeeze out water from wet clothes. The centrifuge machine uses the concept of centrifugal force to separate these components. The third one is, how can we separate a mixture of two immiscible liquids? A separating funnel is used in this case to separate a mixture of two immiscible liquids. It uses the principle of density difference in the components of two immiscible liquids. We take a funnel which has a stopcock, and when we put the mixture, the two components separates because there is a difference in density of both. When the stopcock is open, water gets separated out, and as soon as the water gets separated out, the stopcock is again closed, leaving behind kerosene oil in the funnel. Now, some of the applications of using a separating funnel is to separate mixture of oil and water, and in the extraction of iron from its ore. The lighter slag is removed from top by this method to leave the molten iron at the bottom in the furnace. The fourth one is, how can we separate a mixture of salt and ammonium chloride? In this case, ammonium chloride is volatile and sublimes on heating, and it gets deposited at the neck of the inverted funnel. Salt, which is a non-volatile component, is left behind in the china dish. The experimental setup of this experiment is a china dish which is kept on a burner, and in this china dish we have taken the mixture of ammonium chloride and salt. An inverted funnel is kept over this china dish and the burner is heated. Now, as soon as the burner is heated, the ammonium chloride starts to sublime. Getting in contact with the surface of inverted funnel, it gets deposited on the neck, and this way we can separate the two components. Now, the fifth is, how can we check if the dye in the black ink is a single color? For this, the technique of chromatography is used. The experimental setup of this is to take a strip of filter paper and to draw a line with a pencil on it, as shown in this figure. Now, a spot of ink is placed on this line. Now, this strip of filter paper is slowly inserted into water, till the point when water reaches just below the line drawn by the pencil. Now, as soon as the water reaches that point, it starts to get absorbed in the strip of filter paper and starts rising upon the filter paper. Now, due to different colors having different solubility in water, we can get separate colors out of the dye in black ink. Hence, we can say that the dye in black ink is not a single color. The applications of chromatography are to separate colors in a dye, pigments from natural colors, and drugs from blood. The sixth one is, how can we separate a mixture of two miscible liquids? Earlier, we had seen separation of two immiscible liquids. Now we will see separation of two miscible liquids. In this case, distillation is the process that is used. It works on the principle of different boiling points of the component liquids present in the mixture. To separate a mixture of the two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, a different technique called the fractional distillation process is used. For example, for the separation of different gases from air, different fractions from petroleum products, etc. The apparatus is similar to that for simple distillation, except that a fractionating column is fitted between the distillation flask and the condenser. So for this we need to see the experimental setup. The experimental setup consists of a flask which is kept on a burner. The top of the flask is covered with a cork and a thermometer is placed inside it. Now a channel is made which is passed through a condenser, and finally a beaker is placed at the end of the condenser. Now a mixture of acetone and water is kept in the flask and heated. As acetone is volatile, it starts boiling before water. Its vapors then passes through condenser and gets condensed due to cold water that runs through it. And finally the acetone is collected in another beaker, leaving behind water in the original flask. So this is how a distillation process works. The picture here shows a fractional distillation column. The difference between a fractional distillation column and a normal distillation column is that there is a fractionating column which is present before the dispenser. The vapors passes through this fractionating column and get separated according to different boiling points of the components present in the mixture. Hence it can be used for more than two components present in the mixture. The seventh one is, how can we obtain different gases from air? Air is a homogeneous mixture and can be separated into different components by the fractional distillation method that we discussed just before this. Air is compressed and cooled by increasing pressure and decreasing temperature so that it liquefies. Now it is allowed to warm up slowly in the fractional distillation column. Gases get separated at different heights due to the differences in the boiling points of the components that are present. The eighth one is, how can we obtain pure copper sulfate from an impure sample? In this case, the crystallization technique is used to purify solids. Crystallization is a process that separates a pure solid in the form of its crystal from a solution. Crystallization technique is better than simple evaporation technique as some solids decompose or some, like sugar, may get charred on heating or to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solid. Some applications of crystallization are purification of salt that we get from seawater and separation of crystals of alum, which is also known as fitkari in Hindi, from impure samples. Now let's briefly discuss a water purification plant. We all have water purification plant in our cities to get clean water. Water from the reservoir is first passed into a sedimentation tank where the solids are allowed to settle. Then it passes through a loading tank to sediment the suspended impurities. The next step is the filtration tank. In the filtration tank, fine impurities are filtered out of the water. In the end, it is passed through a chlorination plant to kill the bacteria that is present in the water, and in the end, this water is supplied to homes. Now the topic comes physical and chemical changes. The interconversion of states is a physical change because these changes occur without a change in composition and no change in chemical nature of the substance. The chemical change brings change in the chemical properties of matter and we get new substances. A chemical change is also called a chemical reaction. So what are the types of pure substances? On the basis of chemical composition, substances can be classified as elements and compounds. So first let us discuss what are elements. Scientist Robert Boyle first coined the word in 1661. Antoine Lavoisier established the experimentally useful definition of element. The definition of element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can normally be divided into metals, nonmetals, and metalloids. Metals usually show some or all the following properties. They have a luster, that is, they shine. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile, that is, they can be drawn into wires. They are also malleable, that is, they can be hammered into thin sheets. And they are sonorous, which means make a ringing sound when they are hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, and etc. Mercury is the only metal that is liquid at room temperature. Nonmetals usually show some or all of these following properties. They display a variety of colors, they are poor conductors of heat and electricity, and they are not lustrous, sonorous, or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, and etc. Some elements have intermediate properties between those of metals and nonmetals, and these are called the metalloids. The example of metalloids are boron, silicon, germanium, etc. On the basis of chemical properties, the second type of substances are the compounds. A compound is a substance composed of two or more elements, which chemically combine with one another in a fixed proportion. So what do we get when two or more elements are combined? When two or more elements are combined in such a way that there is a chemical reaction between them, we obtain a compound. The composition of compound is same throughout, that is, it is homogeneous. We can also observe that the texture and the color of compound are same throughout. This slide summarizes the differences between mixtures and compounds. In mixtures, elements or compounds just mix together to form a mixture and no new compound is formed, whereas in compounds, elements react to form new compounds. In mixtures, a mixture has a variable composition, whereas in compounds, the composition of each new substance is always fixed. A mixture shows the properties of constituent substances, whereas in compounds, new substance has totally different properties. The last point of difference is, the constituents can be separated fairly easily by physical methods in mixtures, whereas in compounds, chemicals or electrochemical reactions have to be applied in order to separate the constituents. Matter can be divided into pure substance and mixtures. Pure substance can be further divided into elements and compounds. And mixtures can be further subdivided into homogeneous and heterogeneous. The properties of elements are that it cannot be broken down into simpler substances, for example copper, oxygen, iron, hydrogen, mercury, etc. The property of compounds is they have fixed composition, can be broken down into elements by chemical or electrochemical reactions. The example of compounds are water, methane, sugar, salt, etc. Homogeneous mixtures have uniform composition throughout, for example, sugar in water, salt in water, etc. Whereas heterogeneous mixtures have non-uniform composition, examples of which are sand and salt, sugar and salt, wood, blood, water in oil, etc. With this, we come to the end of this chapter. Thank you.